What if all that quantum strangeness isn't a hint that we're in a simulation, but is instead the best evidence we have that we are not? This is where a landmark 2017 study by two physicists, Zohar Ringel and Dmitry Kovarzhin, comes in. They weren't even trying to debunk the simulation hypothesis. Their work was far more technical, focused on the challenges of simulating quantum systems on classical computers. But in doing so, they ran headfirst into a roadblock so fundamental it threatens the entire simulation idea. They were tackling a notoriously hard problem in physics called the quantum sign problem. To put it simply, when you try to simulate quantum systems with lots of interacting particles, the calculations spiral out of control and become impossibly complex. It's not just a case of needing a faster computer. The difficulty doesn't just add up, it multiplies exponentially. For every single particle you add to the simulation, the computing power needed skyrockets. Ringel and Kovarzhin proved that for certain quantum phenomena, this sign problem is basically unsolvable for a classical computer. It's not a temporary hurdle we can clear by just building bigger supercomputers. To give you an idea of the scale, they calculated that just to store the information needed to accurately simulate a system of a few hundred electrons, you would need a memory bank built out of more atoms than exist in the entire known universe. Let that sink in for a second. You can't build a computer inside our universe that is powerful enough to simulate even a tiny piece of that same universe's quantum reality. The program would be infinitely more complex than the machine trying to run it. This just shatters that neat video game analogy. A game only has to render a simplified visual surface. But our universe, even when no one is looking, has to uphold an underlying layer of quantum rules that are so ridiculously complex, they appear to be non-simulatable by any computer we can conceive of. Now the obvious question is, okay, but what if they're using quantum computers?